Okay, as a reminder, we're going to use substitution and elimination. I'm going to do one of each, so you've seen them both today. This one I'm going to do elimination. To use elimination, everything has to be lined up, the things that go together, like all the x's, all the y's, the equal signs, the constants, they all have to be lined up. They don't have to be in this order. They all have to be lined up. Okay. Bye. Noel? Leaving? Do you know? Does he know he's leaving? You know you're leaving? Okay. The assignment is going to be in the book. I'll post the numbers on Canvas. Okay. All right. So what I need to do is I need to either make the x's or the y's opposites. Opposites mean if I add them together, it equals 0. When I look at these numbers, it's much easier to make the x turn into something that cancels out with 2x, and it would be able to make the y's the same number, but opposites means same number, one's plus and one's minus. So if I take this first equation, if I multiply everything by -2, when I add the two equations up, my x's make 0. Bye. And then I'm going to add up my y's. I'm going to get 5y equals -5. Divide both sides by 5. We get y equals -1. Then what do we do with that number? Plug it in. Plug into one of the equations. It doesn't matter which one, but I always use the first one, make it easy on myself. Like I always go in the same order. So we're going to plug in 1. And then check in 2, yeah. So plug in 1. So we have x minus, it ends up being +4 equals 9. So x has to equal 5. And then we check in 2. So we'll have 2 times 5 minus, so it'll be +3 equals 13. That's 10 plus 3. Yep, that checks. And then we write our answer as an ordered pair, 5, -1. So remember what this really means graphically is where do these two lines intersect on a graph? Okay, that was elimination. Substitution, what you want to do first is you want to have one equation that is solved for one variable. Or you can have both equations solved for the same variable, but you have to have at least one equation where it's either y equals or x equals, which I already have. Then what we do is we put in what y equals. So I'm going to rewrite 3x plus 5 times 2x equals 0 because y is 2x. Now I'm going to simplify this. I'm going to have 3x plus 10x equals 0. These are like terms. So I've got 13x equals 0. Divide by 13, and we have x equals 0. Found one answer, what do I do? Plug in 1, right? So y equals 2 times 0. So what's y equal? 0. Okay, what do we do? Check in 2. So 3 times 0 plus 5 times 0 is 0. Is that true?
Yes.
Okay, so my answer is 0, 0. That was substitution. So that's basically what we're doing today. The only kind of new stuff is that we're going to have a system of non-linear equations. So linear would be like y equals 2x plus 5. That makes a line. But nonlinear would be y equals x squared plus 2x minus 4. What kind of equation is this make? Quadratic. Oh, that same stuff we've been studying for like 2 chapters straight. Okay? If I have a parabola and a line, we have lots of different situations. We could have no solution where they do not cross ever. We could have one solution where the line is what's called tangent to the parabola. You guys remember tangent from geometry, except for those of you that have not completed geometry yet? Comes later in the year. Maybe you remember tangent before that. Do you remember? I didn't know it. I don't know when it
Isn't
first.
that on the calculator and you press like,
Yeah, that's a different kind of tangent.
Tan and tan.
That's tangent of an
like,
angle.
if someone suck a toe up, like,
No, that's the other kind of tangent. Tangent in geometry, you guys used when you had a circle, and then you had a line that like just touched the circle one time, the tangent line. So that you can have tangent to other graphs besides circles. And if you end up going all the way to calculus, this ends up being pretty important in calculus. What, Martin? Mm-hmm. He said logarithms.
oh, that's
No, it's a really easy chapter. It's a really easy chapter. Two solutions would be another situation that you could have. Okay? But we could also have like two parabolas that we're solving between. If we have two parabolas, it could be no solution. It could be one solution if they both meet just once. It could also be two solutions. Okay? So those are different situations that we might have. Okay. What? There cannot be four solutions. Can you draw two parabolas that cross 4 times? Don't draw it right there. Draw off to the side, because I'll just mess with my computer. So now one of those we have not learned about. One of those parabolas, the one that turns sideways, we haven't learned about that yet.
So it can't be four solutions.
Yeah, we're not going to have that, though.
Okay.
Okay, because we haven't learned about those. I got it. You will not have those in any of these assignments until we've learned about those, which we learn about at the end of section 5. And we haven't even hit 4 yet, so. And then section 6 is logarithms.
But there could be four solutions.
There can be. You can also have 4 solutions if you have like a circle and a parabola.
What would that be called?
I don't know what you mean. What would that be?
Four
4
solutions.
solutions, yeah.
A quad. It could be. Quad.
No, you don't. We don't have like fancy names. I guess you could even have 3 solutions with a parabola and a circle. Names for that. Okay, what we have to do for today and for Friday is we have to review how to graph things by hand. Okay. So how do we graph y equals x squared minus 2x minus 1? What kind of information? Let's go with equation number 1. What kind of information can I find from this? What kind of graph is it?
It's quadratic.
It's quadratic. Could we put it in vertex form?
Yes.
That should be pretty easy. These look like easy numbers. Let's put it in vertex form, because if I put it in vertex form, I can find the vertex. Or I have other ways I could find the vertex. Maybe we shouldn't put it in vertex form. I'm looking at what else I have set up here. Do you want to put in vertex form, or do you want to do negative b over 2a to find a vertex? I don't care. We just took a quiz on doing it in vertex form. But so maybe we should review negative b over 2a. Maybe we should review that. Let's do that. Let's review it, because it's going to be on your exam in December.
Because it's study guide for you.
Yes.
Okay.
But that doesn't mean you always do it. I gave you 2 study guides for this past our quiz. All right, x equals negative b over 2a is how you find the axis of symmetry. So we do negative 2 over 2 times 1, oops, which gives me x equals 1. So that's my axis of symmetry, x equals 1. It's a really dark graph. It's my axis of symmetry for equation number 1. Can't really even see that. Here, I'll do it in a different color. Do you have a question on this, or are you guys just talking? I just want to make sure I'm answering questions, or if I should just ignore it because you're just talking.
I did it wrong, and then I was like, wait.
Okay, so now how do we find the vertex if we know the AOS? Okay, so we're going to plug it in. We're going to have 1 squared minus 2 times 1 minus 1. So that's 1 minus 2 minus 1. Negative 2. That's my vertex. If you're sitting too far back and you're having trouble seeing, you can upgrade your seat. 1, negative 2. Yeah, sorry. It doesn't all fit on the thing at the same time. It isn't it negative 2? It is negative. Just double checking. What also can we find from this equation besides the vertex? What else can we find? Y-intercept. What's the y-intercept?
0 equals
What?
what is 0 for
Oh, plug in 0 for x. You were saying how to find it. I was saying what is it? But yes, plug in 0 for x. What is our y-intercept? 0, negative 1. We write intercepts as ordered pairs. So 0, negative 1 is my y-intercept. What else can I find? Maybe. I'm looking at it and it's not factorable. So if I try to find my x-intercepts, they're going to be yucky to graph. Okay? But somebody said something. I heard it. What, Afni?
I don't know how to explain it, but it's
Okay, so
2 negative
the reflection.
Yeah, the
Yes, the reflection of this y-intercept. Remember, there's a mirror point. That's why I called it a mirror point. Oh, thank you. Okay. I'll tell my husband. Okay, now, is that enough? Okay. Too many people talking. Rachel?
Can you guess like a number that's close to like when you plug it into like x?
Yes. So we could plug in what number? What are you thinking? Right. Or you could probably both of them. There's another way of graphing this. Excellent way. There's an easier way of graphing this. Does this have a stretch or a shrink? So do you know those like patterns of just? That's why I made you do that one day where you did copy it like 22 times. That's why I made you do it. So now we've just saved us some time. If you go out 1, up 1, you either go out 2, up 4 from the vertex, or some of you say out 1, up 3 from previous point. Whatever your pattern is, you can actually get even more points than the minimum. So I'll make this one blue. Mm-mm. No, people use them all. I did a good one, didn't I? I did. That doesn't always happen. And I did it using not erasable pen too, so that was great. Maybe my brain has returned since this morning.
Yeah.
I did drink caffeine earlier today, so yeah. Okay. All right, so I have that one graphed. Now we're going to graph equation number 2. And what do I know about equation number 2?
It is linear.
It's linear.
Oh my god, that's what the equation is.
So I can find the slope and the y-intercept. What's my slope? And my y-intercept is, so 0, negative 1. So 0, negative 1 is my y-intercept. And then I go from there, I move down 2 over 1. Down 2 over 1. Now I'm going away from the parabola, so it's probably not that direction. I can also go up to left 1. Up to left 1. Oh no. I graphed that wrong. I've made such a good parabola and I graphed it wrong. Up to left 1. Up to left 1. I put these points right here in the wrong spot.
Yeah, you're supposed to go into.
Oh, I'm supposed to go up. No, those are in the right spot. Are they, or are they wrong?
I think is it wrong?
No, they were right. It was right. You put that
Oh, I know what's wrong. Never mind, Avneet, my brain has not returned. I did something else wrong. Can you guys see what I did wrong?
Oh yeah, then you go down.
No. No, I know what I did wrong. No, I know what I did wrong.
Isn't that your y-axis? It's kind of
Where is my y-axis?
To the left, to the left.
Like I used my axis of symmetry instead of my y-axis. It's so dark, and then I just confused myself.
I did that too.
Yeah.
Oh my god, I did that. I didn't either.
I probably did that because you put the
I need to
0,
write it
negative
just
1 in between those two things, so I thought that's just right.
Blame someone else for your action.
I'm not blaming anybody else. I made that mistake. Here's a straight
I
edge.
made a mistake.
I did make a mistake. It only happens once a year.
Once a year. Once a class
It only happens once a year. You guys are lucky. You saw my one time a year. So don't look at the red dots. Look at the green dots. Where do the two graphs intersect? So you think. But if you graphed it wrong, like I did the first time, we got to check it. We have to check it because it.
Did you got the parabola wrong?
No, I graphed the line wrong at first. The red points are wrong, the green ones are right. We're going to guess it's at 0, negative 1. How do we check that we are correct? You plug it in for x and y in what? Both. So we're going to check in equation 1. We're going to do y should be negative 1 when x is 0. Does that equal negative 1?
Yes.
Check. I'm going to try it in equation 2. I'm going to make y negative 1. I'm going to make x 0. So I get negative 1 equals negative 1. We are correct. So this is our answer. But you have to treat it as a guess at first because it's possible you might grab something wrong like you just saw me do.
Well, what if the 0 is multiplying to negative 1? In the first one, in the check.
I don't know what you're talking about, hon.
Okay, so.
It wouldn't check. You would be wrong. That would tell you you've graphed something wrong. If it doesn't check,
No, like, it's, like, how do you know it's negative 2 times 0?
because I'm using this equation right here. Okay, example 2, solve by substitution. Ready? We're going to solve by substitution. So substitution is when you solve one of these for one of the variables, you plug it into the other. Which equation should we say either x equals or y equals to? Okay, let's use equation 2. I'm going to suggest that whatever equation has like the squared and the regular variable in it, whatever equation has the squared and the regular variable, replace the other variable. We want to change y into more x's. That is the easiest way of doing this. That means I'm going to solve this one for y. If I want to replace y, I have to solve for y. If replace y, solve for y. So I'm going to take my second equation. I'm going to have y equals 4 minus x. So now I'm going to substitute that in the first equation where y is. So my first equation is going to end up being x squared plus x minus sign parenthesis 4 minus x equals negative 1. So I replaced. Now if I have all x's, I can solve. If I had x's and y's in it, I couldn't solve. So now I have all x's, I can solve. So I'm going to simplify this. I need to distribute that negative sign. X squared plus x minus 4 plus 4x equals negative 1. Combine some like terms over here. I've got x squared plus 5x.
Wait, you combined the negative 4 with a 4x?
No, 4x. These are like terms.
Oh, that's what you meant.
Wait. It should be just x.
Oh, I made a, oh gosh. Thank you.
Once a year, mine.
That may have been an over-exaggeration of what really happens in my life. How many times did I say that in geometry today?
So many.
So many times, because I was not awake, I don't think. Okay, so here we go. So I combined my x with my x, and I got 2x, okay? So now I need to solve this. That is a quadratic equation. We just took a quiz on it. How do we solve it? If I'm going to factor, what do I have to have first?
Equals to 0.
You could complete the square too. What also could you do? Let's see if it factors, because in my opinion, if it factors, that is the shortest, fastest way. You do not have to do it the way I do it, but if it factors, I'm going to factor it. And it does factor. If you want to use quadratic formula for everything, that's your choice. So I factored it. And then what do we do for each factor? So x equals -3, x minus 1 equals 0, x equals 1. How am I writing my answers, though? Is this an ordered pair?
No.
Oh my God, plug it in.
If I have two separate x's, what does that mean about how many answers I have?
Those?
There's two answers. So these are the x's for my two answers. So now we have to...
Say or and. Well, like, you have to choose, like,
No, it'll be and. It'll be both.
and.
So what I have to do is I do have to plug this in. I have to go back and plug it in separately. So we're going to, and it doesn't matter which one you want to use, but I always use one first. If you want to use two first, that's fine. You don't have to follow what I do. I just always plug in one.
Are you meaning we have to plug in both x's into one and both x's into two?
Yes. Yes. I'm just going to stay organized. So I'm going to plug in -3 into all my x's for the first equation. -3 squared plus -3 minus y equals -1. So 9, and you can use your calculator if you want. It takes me too long to type it all in. I just do it by hand. So 6 minus y equals -1. Let's do a little switcheroo here. I'm going to add 1, and I'm going to add y. So get y equals 7. Okay, then I also have to plug in 1 into that same equation. So I'll have 1 squared plus 1 minus y equals -1. So 2 minus y equals -1. If I add 1, I add y.
Why'd you do the longer?
It doesn't matter. Why did I pick the first equation?
Plus y equals 4, and you're
I'm gonna have to use both of them. Like, you're gonna have to use both of them. It does not matter which one you do first.
do it like 4 times then?
Yeah.
Oh.
So my second answer is y equals 3. So now I have to check in 2, but I have two answers to check. My first answer I'm checking is when x equals -3 and y equals 7. And my second one I'm checking is when x equals 1 and y equals 3. So I have to check both of those situations. But I'm checking it in equation 2, so I'm going to have -3 plus 7 equals 4. Does that check?
Yes.
Then I have 1 plus 3 equals 4. Does that check?
Yes.
Okay, so then both of my answers do work. My answers will look like a collection. -3, 7, and 1, 4. You want to make money someday? You're going to have to do too much. Is that Katie asking me a question? What's your question, Katie?
They become sex.
For what? This?
Yeah.
It equals.
It is -1.
Did I do it wrong or you did it
No,
wrong?
I did it
Okay.
wrong.
Katie, do you see what you did wrong or not?
This equation is equal -1. I put equal 1. I did -1.
Okay, so Katie, did you do the same way I solved it or did you move the 2 over?
I thought it was 0. I didn't get it was 2.
Well, this is 1 plus 1. Did you subtract them? Did she subtract them? Like, for you to get a 0, like, you're plugging in 1 squared plus 1.
For the thing, I did x plus 3, x plus 1. So when I factored it, I did the wrong side.
Oh, you're your wrong signs for factoring. Got it. All right. Then example 3 is solve the system by elimination. So we have equation 1, equation 2 again. Elimination is where you would add them up and something has to cancel. You want to completely cancel the variables. So, yeah, we've lucked out for this one. But when I look at it, if I'm looking at my variables, I can't cancel out x squareds and x at the same time. You can't. So you're going to try to cancel out the y's. Now, if you look at this, I would hope you'd go for the y's anyway because they already cancel out. But you want to try to cancel out the ones that there's just like a single variable, doesn't have it as squared and regular. Try to cancel out the one that doesn't have multiple versions of itself there. So we add these together, we get 3x squared minus 3x equals negative 2. So we did elimination, we have only x's. What should we do to solve it? Add 2 to both sides. Now what could we do to solve it? Does it factor? It's not factorable. So what can we do instead? I'm not going to want to do complete the square. You know why? Because there's a number in front and this is odd. So let's do the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. That's why we sing it.
Forgot the minus 4.
That's why we sing it. That's part of the discriminant.
I know, I wasn't here for this on Friday.
And did you watch the video and sing along?
No.
Okay. So we do opposite b plus or minus square root 9 minus 4 times 3 times 2 all over 6. So we get 3 plus or minus square root of what? 9 minus what? 15, negative 15? Is that what we get? Am I doing that right? Okay, I'm going to stop because I already know the answer. I know the answer already. What happens if you have a negative square root? It's imaginary. So can these actually cross at an imaginary answer? Nope. This is no solution. Okay, the last one that I want to show you in 5 minutes is circles. So this right here is an equation of a circle. X squared plus y squared equals radius squared. The r is radius squared. X squared plus y squared equals radius squared. Totally related to a squared plus b squared equals c squared, just so you know. It's totally related to that. Okay, when you graph a circle, if it is in this format, the center will be at 0, 0. And from there, the radius is the same amount. You know how circles work. The radius is going to be the same amount all the way around. And a point on the circle would be xy. When we do equations with systems with the circles, you could have no solution. You could have a tangent, one solution. You could have, ooh, anybody remember what that's called?
No, I was going to think.
Secant, that would be tangent. Just bringing up some geometry love, and some of you. I don't know what you're saying.
So, like, for the other one, we didn't label the...
No, yeah, it's because I don't know if they're called, I can't remember if they're called that with parabolas.
Yeah, it's just
I could look it up, but I don't remember if they are. Hi. Yeah, I got like one example to get through. You just like hang out and learn some stuff. It's algebra 2. All right, so example 4, we're going to solve with a circle. So that first one's the circle, and then what's the second one? Linear, okay. So we're going to have a line that may or may not cross. So when we go to, when I look at this, I cannot use I cannot use elimination because I have an x squared in this one and I don't have an x squared in this one. So I cannot eliminate. I have a y squared in this one, but I don't have a y squared in this one. I cannot eliminate. So what's my choice? Substitution. I could probably also graph, but I don't know how to graph square root of 10 for a radius, so we're just going to use substitution. Oh, in the directions, do you say substitution? That part I didn't read. So I'm going to solve, since this one's already y equals, I'm going to solve that. I'm going to set that one, replace that one in the y squared. So we'll have x squared plus parenthesis negative 3x plus 10, close parenthesis squared equals 10. So we now have just x's. However, I need to collect some like terms, and I can't do that because PEMDAS says square before multiplying or adding. So I need to square this. How do I square that? Don't kill a puppy. Don't kill a puppy. Now you do like the box method or the FOIL method. In order to square it, you have to write it twice and multiply those together. You can do your box method if you like that way, or you can do the FOIL method if you like that way. Because of time, I'm going to tell you what the answer is. Okay? I mean, you're going to do it on your own, but I'm just going to tell you real fast. It's going to be negative 60x plus 100 equals 10. Yeah, that's really easy. 10x squared. I'm going to subtract 10 from both sides. I've got minus 60x plus 90 equals 0. Okay, so what should we do? What factors out? Could I actually just divide both sides by 10? So instead of factoring that 10, now you cannot do that with x's, but you can do that with just numbers. So I can have x squared minus 6x plus 9 equals 0. Does that factor? Yes, 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 yes. It's x minus 3 squared. So what would x equal?
X equals 3.
Okay, so how many solutions will I have for this one? Right. So now we need to plug in 1 and check in 2. Or you can plug in 2 and check in 1. If you like that way easier, because you're plugging in a line and then checking in a quadratic, that'd be fine. Let's plug in 2, because I'm thinking ahead right now. Let's plug in 2. So y equals negative 3 times 3 plus 10. So negative 9 plus 10. What's y? 1. And then we're going to check in 1. Doesn't really matter which one's first, but you got to plug and check in both. So then I have negative 3, no, sorry, it's positive. Positive 3 squared plus 1 squared equals 10. So that'd be 9 plus 1 equals 10. Does it work?
Yeah.
So we have one answer at 3, 1. Okay, that was bare minimum kind of notes today. We didn't even get to the back. So we'll have to do this part on Friday, which is not a problem. No, I have homework. You just won't be able to do the last part of it. This is with a graphing calculator. So you want to make sure you bring your graphing calculator. Oh.
How many questions can we not do on the homework?
I'll tell you. They're coming. It's popping up right now. So for the homework, and I'm still recording, for the homework, you will not be able to do the last 3. I mean, you might be able to do if you just look in the book. It's really easy. But those are the last 3 that I didn't get to. If you have questions, bring it. We're coming next week. Yes, you have to use your online book. Remember, you can get to your online book through Big Ideas. You open your online book. I will post it on Canvas. I'll post it on Canvas. Let me just stop the recording. Hold on. You can hear.